Right, good afternoon, everybody. Welcome to this webinar on Fume events, managing Fume events. Right, so let's get into it. The agenda that we're going to go through today, we'll first talk about the health aspects of this. But as you know, none of us are medics, so it's not something that we want to dive into. And really what we're about today is talking about the procedures and how to handle these kind of events in the operation and what the follow-up actions should be. So we'll talk about those procedures. And I've then got a few example events to go through and then a bit of a discussion. I'm sure you're all aware that unless it's a 787, which compresses the cabin air electronically, other aeroplanes take an air supply from the engine and use that to pressurize the cabin. And that's where if there are any contaminants through any leaky seals or other issues with the engine could potentially get into that cabin air. Usually the cabin is pressurized to around 8,000 feet, and the cabin air is recycled quite frequently as well during the flight. So the health issue, there's a thing called aerotoxic syndrome, which is a range of symptoms and signs that are described as being wide-ranging and inconsistent. In other words, this kind of event affects everybody differently, and they can't really put their finger on one set of symptoms. And as a result of that, the medical status is still currently, it's not recognized as a clinical diagnosis or classified as a disease. And the reason they put that down to is that the toxins are below what's considered to be a safe working level, but everybody's sensitivity to those contaminants in the air varies, and that's why most people have no effect and some people have, and then that ranges all the way up to people having some quite severe reactions to this. Like I said, this is a medical area. It's quite contentious. There's loads of information about this on the internet if you want to look at it, but it's not something that we're experts in. And that's really the status of it as of today. The webinar will really focus on the operational response to these events. So this is a quote from the CASA Australia guidance document, which we'll draw on a bit today. And I'll read it to you. It says, exposure to oil or hydraulic fluid, fumes or smoke can in some cases lead to crew members experiencing acute symptoms in flight. Such exposure has the potential to impair crew performance and affect safe operation of the aircraft. It is therefore important that crew members are able to recognise, respond to and promptly report such events, as effective management and reporting support ongoing operational safety and awareness. So that really builds on that point that we do have to take these seriously because the effects on some people can be quite significant. And so dealing with it in flight is important, doing it the right way, but also then the level of reporting and the detail of the reporting also important too, in order that the follow-up actions can be comprehensive and appropriate and effective. So what do we mean by fumes? Well, again, it's a definition in the CASA document of a gaseous, often odorous compounds which are not necessarily visible, but may be irritating, offensive or noxious. So unlike smoke, which is clearly visible, fumes may not be, or they may be faint in terms of their visual signs. But however, they're not to be, whereas smoke is clearly something that has to be treated seriously, these should be too, because they are potentially noxious and they can be operationally disruptive, because that's going to increase the workload of everybody and put huge demands on the cabin crew and the flight deck. So last year, the UKCA published a safety notice 008, and this talked about odours, and they encourage operators to have suitable procedures for a smell stroke odour event that are not smoke stroke fume events. And this is this requires a differentiation. What do we mean? What's the difference between the two? And they describe these as procedures to address benign odour events. So I think the first thing about this in flight is that you have to follow the procedures and treat it the same, but through the development of that and the troubleshooting, it may be possible that ultimately, as a crew, you decide that this is just a benign odor rather than a more noxious fume event. On top of that, they do want operators to make sure that they do have the procedures, training, and checklists and so on to manage fume events and to differentiate between what is a benign odor and a smoke fume event appropriately. I think the key for this is that at the start you treat it like it could be the worst case, and as that develops, you then modify your approach. And the reason why it matters is that there could be a benign event is obviously not going to have any effect, but when you first recognize it, you may not know whether it's actually a benign odor or actually a more significant fume event. And fumes of smoke are usually hazardous, often noxious, and they obviously have to have the highest level of response. Recognition and understanding of fume events. This is a couple of slides taken from the CASA advisory circular on the management of smoke and fume events. Obviously, recognition is going to be, you're going to smell it, you might even see it, and then the crew have to communicate with each other in order that they're both, the flight deck and the cabin crew, are aware. And this is super important because one or the other may not be aware of it, and one or the other may have some important information that colors in the picture of the information that the other has. So it's super important to make sure that that the communication, once it's recognized, that communication takes place. And the communication side of it is super important. I'd like to tell you a couple of stories. I had a fume event as we were reaching the top of climb. The purser came in and said, "Oh, and because it's that kind of airfield, we took an engineer with us for the turnaround." The purser came in and said, "We smelt some electrical burning from the in-flight entertainment. The engineers disconnected it and it's all fine now." And I said, "Okay, that's good. What I missed, is there anything wrong with that? Can you spot what's wrong with that?" Because I didn't at the time. I thought, okay, that's good. We've got an engineer on board. They've pulled the circuit breakers. It's all good. We carry on. The subtlety of what I missed there became apparent later when the purser came in and said, "Oh, the engineers reconnected all of the IFE and it all looks fine now." And that's when I realized that they were doing stuff in the back of the airplane and they weren't telling me. They weren't communicating. And so I called the engineer in, and in accordance with my human factors training, I adjusted my communication style to suit the situation. And I think he got the message, judging by the first officer's face. And he disconnected the IFE again, and we continued with it disconnected in spite of quite a few passenger complaints. And that was not long after the Swiss Air 111 accident off Canada, which was connected to short-circuiting IFE. So that's communication every step of the way, from the moment you first sense it right the way through. Sometimes communication can get a little mixed up. One of my colleagues was troubleshooting I think it was an overheating hydraulic pump, something like that. And when the crew brought some drinks in and made a passing comment as they left saying, "Oh, it's really smoky in the back." And bear in mind, this was in the late 90s when there was a smoking section in the back of the aeroplane. And they continued their troubleshooting this issue, and they put the two things together and started to divert. And in the descent, there obviously was some more communication with the purser, was when they realized that the two were not connected at all. The back of the aeroplane was smoky because lots of people were smoking, and it wasn't caused by what they were troubleshooting in the flight deck. So communication is really important, and really clear communication and you've got to say clearly what you mean and make sure that it's understood as well. And I would say that after recognizing that there's some kind of smell or odor, communication is probably the most important thing of all. So then when everybody's in the loop, there has to be a decision, and the flight crew will decide which checklist to run and which standard operation procedure applies. And then after the event, the reporting and documentation is also super important, not only for the medical side of it, but for the engineering follow-up. So the type of fumes, where could this be coming from? So in terms of the ventilation supply, as we talked about, the bleed air that's pressurizing the cabin could be potentially contaminated with hydraulic fluid or oil or exhaust gases from the APU or the engine. There is a possibility of de-anti-icing fluids, electrical emissions, compressor wash residues. So that's where the engine's been washed, and there's still a bit of residue there, and that come into the cabin on the first flight after a wash. The cabin is still during de-icing, but again, sometimes you can, after de-icing, you can get a bit of that smell of that sweet smell of de-icing fluid can be smelled, and then electrical smell is another one. And it could be that there's some issue with the fans and the ducting and the distribution of the air. The smoke or fumes could potentially come from something that's been brought onto the aeroplane. Of course, an overheating lithium battery would be a classic. The kind of fluids they use in the galley and the toilet could potentially create smell. Those disinfectants and so on are. And those things used to remove insects, they all have a particular odor to them. Chart really just kind of tries to associate a type of smell to the potential source. The source is important for the flight crew to understand what they might be dealing with, but it's also super important for the engineers, as we'll see when we look at an event later on, in order when they're doing their troubleshooting, in order to figure out where they need to be looking for this. So the smelly sock smell, wet dog, musty, that's usually the one where there's oil. That's what it's normally described as, sort of a sweaty sock smell. If you don't know what that smells like, it's not very nice. I'm sure you've got the idea, but it's a kind of a musty old cheese type smell. That's usually because there's some kind of oil getting into the air conditioning. Hydraulic fluid is more acrid, more pungent, whereas the de-icing one is a kind of a sweeter type smell. It's quite distinct. I think everybody's probably experienced an acrid electrical type burning smell. And fuel, yeah, there can be a smell from fuel. I mean, particularly on the ground, if the aircraft's refueling, you quite often get that whiff of kerosene. Not so likely in flight, but if you know what it smells like, then you would be able to recognize it, obviously. And the other thing you need to remember is that your smell fatigues. If you're smelling the same smell over time, I'm sure everyone's experienced this, then you can start to not smell it anymore. And that's something that needs to be borne in mind. And if you go out of the area and come back in, then you can often quite detect it again. There's limited possibilities to do that in an airplane, but that's something to be mindful of, that it may seem to have gone away, but you may just not be able to smell it. Let's have a look at some training for smoke fumes. Again, this is from the CASA advisory circular. The flight crew, they do training as part of their conversion and recurrent training, and the cabin crew training in terms of recognition and that important part of communication, and then managing the passengers, use of oxygen, and then obviously capturing afterwards what they experienced in as much detail as possible for the engineers. And then the management side of it also needs to be covered as well, because there needs to be some comprehensive follow-up, both in terms of the health of the crew, but also in terms of the troubleshooting with the engineering and the monitoring of the reporting and the trends there. This is a list of the kind of things that should be covered in cabin crew training. We've talked about recognition. We've talked about understanding the potential sources, and then possibly from the type of smell, being able to narrow that down to a particular source. I think we've covered the importance of clear and unambiguous communication so that everybody is on the same page, and that has to be ongoing. Any small changes in the situation have to be communicated both from and to the flight deck. You've got to keep everybody in the loop so everyone knows what's happening, going on. Passenger and cabin management. It may be that some passengers need a bit of oxygen, needs a bit of first aid, need a bit of reassurance. So that's obviously going to be something that needs to be covered in the training. And then the post-event procedure is not over when it's over, because the engineers have now got a really difficult job in trying to reproduce this event in order that they can fix it and stop it from happening again. And so that documentation and reporting is super, super important. This is a kind of list going into a bit more detail on what should you say? Well, the nature and intensity of the fumes. Are there any visible signs such as haze or mist? Have you detected a source? Do you think you know where it's coming from? When was it first noticed? Was it in the climb? Was it in the cruise? And then talk about the flight deck and the cabin crew, talk about what the next actions are, what the cabin crew are going to do. Are the flight crew going to divert? Those kind of conversations need to go on. And then the use of personal breathing equipment is certainly a major consideration, because that's, as a precaution, going to be important to make sure that none of the operating crew are affected to the extent that they can't carry out their duties. And then we talked about the status of the passengers and crew in terms of how they're being affected by it. Moving on to reporting and investigation. Again, this is some notes from the CASA guidance document. Reporting is really important, but the detail and the information that you give the engineers is going to be so helpful to enable them to be able to pinpoint where it's coming from, because if it's vague, they've got to check everything to try and figure it out, and trying to reproduce that on the ground is extremely challenging. So every tiny bit of information, as much as possible, if that reporting can have standardized terminology and consistent phraseology, that's going to help them a lot. Of course, it will be a mandatory occurrence report, and that's important for the CAA to gather all of that information together and see where the issues are, see where the trends are. And then there's going to need to be an investigation. The first thing is going to be an engineering one, but it's also going to be part of the safety department, looking at which airplanes it's happening on, which engine types are happening on. Is there a trend for them to identify for potential additional mitigating actions? But the majority of the post-event work is going to be done with engineering. And then, of course, good reporting promotes good safety management, and then good communication of that back to the operational staff. So looking at the maintenance procedures, this was something that was shared by one of our members. After that CAA notice came out about the differentiation between an odor event and a fume event, they came out with this 2-event pathway. They have a pathway A, odor, smell only, and a pathway B, visible smoke and fumes. And you won't be surprised to know that one of them is more escalated than the other one. They still treat the odor event quite seriously and do all the inspections and so on. They don't return the aircraft back to service until all the actions are acceptable. The visible one is potentially the aircraft's going to be AOG until they're absolutely 100% sure that it's sorted out. In terms of the flight crew, their drills, their procedures would be the same as we've just discussed. This is pathway A, an odor. The crew reports it to maintenance in the tech log. They raise an air safety report, and then the maintenance part 145 informs the camo, and camos offers support where needed. They do all the visual checks in relevant or reported areas of concern where they would potentially be looking, but obviously the aircraft maintenance manual is the primary reference for this. Engine, air supply, avionics, electrical bays, cargo, and adjacent areas. Landing gear, wheels and brakes, overhead panels and wiring, and cockpit sensitive areas would typically be the kind of areas where they would be doing a visual inspection to try and find the source. And that may be a lot easier if that reporting from the crew that experienced it is extremely detailed. And then this is the pathway B, where the crew do their thing, and depending on whether the aircraft returns to base or diverts will depend on how much of a risk assessment they need to do. And the aircraft is then grounded and contacts the OEM for AOG support. And then they do the inspections based on the evidence in the reporting to try and identify the area, fix it, I guess you'd say. So this branch is obviously at much higher risk, and therefore it's treated much more seriously. So that's what one of our members did in response to that CAA odor event safety notice. They had two different two different pathways for engineering to respond to it. And these are their release to service decision gates. All the actions have been completed and controlled. Camo is satisfied and the OEM input has been considered where appropriate. They've established the root cause and they've taken OEM advice for further monitoring. If no root cause is found, that is a possibility that nothing is discovered. And then any OEM requested inspections have been communicated to their 145 and completed. So it uses that release to service as the control point for making sure all of this stuff has been completed prior to the aircraft being released. Right, let's have a look at a few case studies. So I had a look at a year's worth of data in the air safety network. So bear in mind that the ASN is a wiki, so it depends on people putting the events in there. So it's not a comprehensive global database of events. But in that period from May last year to May this year, there were 15 events that were fume events, not fire and smoke, just fumes. As a result of that, there were 6 air turnbacks, 8 diversions, and 1 rejected takeoff. In all cases, they either turned back, diverted, or didn't get airborne. That would seem that, based on everything that we've said so far and your procedures, that would seem to be the appropriate response. This is a Boeing 757 event that was investigated by the AIB. There was blue haze observed in the cabin and the aircraft diverted to Stansted and evacuation was carried out. The haze could not be reproduced on investigation, which included ground runs. And later on, higher power ground runs identified the source as engine number 2, and the cause was a fractured number 1 bearing floating seal ring, which allowed engine oil into the bleed air system. And the AIB made a recommendation that the Boeing 757 fault isolation manual to require ground running at higher engine power settings if the initial testing fails to identify the source of smoke or fumes in the conditioned air. So that would seem to make sense. This is the challenge that engineering have. It is trying to reproduce the conditions, cause the event in the air, reproduce those conditions on the ground. Very, very challenging for them, as this event shows as well. This was at 777 in 2017. During the descent into Heathrow, a strong smell of fumes was apparent in the cockpit and the cabin. On the next flight, the aircraft returned to stand due to fumes in the cabin, having taxied for takeoff. Further troubleshooting was carried out by engineering, and the following day, as the aircraft climbed through 8,000 feet after departing Seattle for Heathrow, so on the return from its outbound trip, the crew were alerted to a left engine overheat. And I'm summarizing quite a long AIB report. It's available on the AIB website if you want to read the details, but trying to get the key points on a slide. At the time the incident occurred, the appropriate fault isolation procedure consisted of 2 steps, depending if the fumes were associated with oil or fuel. And this sort of highlights that thing we were talking about earlier, where giving as much detail and as much color to the report that you put in can be so helpful for the engineers, because this maintenance procedure required them to decide, is it oil or fuel? And if it's oil, we go down this road. If it's fuel, we go down this road. In this case, it was decided that it was attributed to oil, and so the fuel nozzles were not inspected. In fact, it was coming from an issue with the fuel system. And what they did afterwards, the engine manufacturer changed the procedure so that if there were fumes detected, the revised procedure includes a requirement to inspect the fuel nozzles, irrespective of whether the fumes were believed to be associated with fuel, oil or fuel. So that made it a more comprehensive inspection, and it covered off 2 potential sources in one procedure. This one was on a helicopter after returning from a training flight. The cabin and cockpit heating was on, and a heating duct failed, causing fragments of duct and insulation material to be discharged through the heating vents. The system was turned off, but the subsequent presence of smoke and smell of burning prompted an emergency landing. So this illustrates that this stuff can come from just about anywhere. There are all sorts of different ways that you can get fumes or smoke into the cabin. And several weeks later, a similar duct failure occurred. The safety action from this report, again, this was an AIB investigation. The aircraft manufacturer published a service bulletin requiring operators to perform a one-off inspection of the heating duct and to modify the installation. On the 24th of April 2024, an A320 operating a positioning flight experienced a strong chemical odour during descent into Dublin. A faint odour was first noticed after takeoff, but intensified significantly, descending through 6,500 feet, prompting the crew to don oxygen masks. The aircraft continued the approach and landed safely. There were no passengers on board, no injuries reported, and the aircraft was undamaged. The flight crew underwent medical checks with no abnormalities detected, although minor symptoms were reported afterwards. As a result of that, and you see a much more comprehensive list of actions, maybe that's an evolution of how these events are treated as time has gone on. Airbus implemented a cabin quality program targeting APU shutdown logic improvements to prevent oil over-servicing, and a redesign of the APU intake ducting to reduce oil ingestion risk, and development of relocated APU air intakes away from contaminated sources. The APU manufacturer introduced improved load compressor seals to reduce internal oil leakage and modified the cooling fan design to improve reliability. So pretty comprehensive changes made as a result of this event. And the operator reinforced correct APU shutdown and oil servicing procedures, introduced a structured engineering order to investigate all potential leak sources, not just the first identified, and improved repeat event prevention, deployed a portable contamination analyzer, implemented APU component upgrades during maintenance, started exploration of air filtration enhancements, e.g. VOC converters, and the development of a bespoke medical protocol for fume exposure cases. So that's right up to date, and that's really a really comprehensive response from Airbus, the APU manufacturer, and the operator. And those other events that we've looked at over time, I think this has been the case that these events are evolved into being treated much more seriously, and there's a much more comprehensive response these days, which is a good thing to see. I started putting together a list of resources for you. Honestly, when I was researching this presentation, there is stacks of so much stuff it wouldn't fit on one slide. There's IATA have got documents, EASA, there's stuff on Skybree, there's Airbus have got a safety first article on responding to smoke events, there's stuff on the CASA website, the FAA website. So trying to list it all would have been impractical. I have, however, put the 4 references from the UKCA website. There's one where they talk about aircraft fume events, another one on cabin air quality. There's a paper that they wrote in 2004, and then they've also got a care pathway, which is a flowchart for medical professionals in dealing with crew that have been exposed to this. So at that point, I will stop talking. You'll be pleased to know. Thank you, everybody, for attending.